Imagine waking up to a sky so dark the sun doesn't rise for years. Ash falls like snow. Crops die, species vanish, and your entire family is one of the last humans alive. This isn't science fiction. It actually happened. "74,000 years ago, the Earth trembled. A mountain in what is now Indonesia exploded with a force 1,000 times greater than any nuclear bomb. The sky turned black. Ash fell like snow for weeks, and the human race almost vanished. This is the story of the Toba supereruption, the most powerful volcanic event in the last 2 million years, and how it nearly ended us before we even began. It all started deep beneath the Earth's crust, where an ocean of molten rock had been building pressure for centuries. The Toba caldera, resting on the volatile Pacific Ring of Fire, was primed to blow. This region, a horseshoe-shaped zone of intense seismic and volcanic activity, is home to some of the planet's most powerful geological forces. The sheer scale of the magma chamber beneath Toba was immense, a ticking time bomb waiting for the critical moment of release. When it finally did, the eruption ejected over 2,800 cubic kilometers of volcanic material into the atmosphere, enough to bury the entire United States knee-deep in ash. To put that into perspective, the 1980 eruption of Mount St. Helens, a significant event in modern memory, ejected less than 1 cubic kilometer. Toba was truly in a league of its own, classified as a VEI 8 event, the highest possible rating on the Volcanic Explosivity Index. The explosion was so immense, it created a crater 100 kilometers wide, today known as Lake Toba, a serene body of water that belies its cataclysmic origin. The immediate aftermath was apocalyptic for the surrounding regions. Pyroclastic flows, superheated currents of gas and ash, would have incinerated everything in their path for hundreds of kilometers. The sound alone would have been deafening, heard across continents, but the real horror wasn't just local, it was global. Volcanic ash blanketed much of South Asia. Ash layers over 2 meters thick were found in India, thousands of kilometers away. This fine, abrasive material would have choked rivers, destroyed infrastructure, and rendered vast swathes of land uninhabitable. The true global threat, however, came from the invisible. The fine particles reached high into the stratosphere, where they formed a dense veil of sulfur dioxide and ash that circled the globe. This stratospheric injection was key to Toba's devastating global impact. Sulfur dioxide reacts with water vapor to form sulfuric acid aerosols, tiny droplets that are highly reflective. These aerosols acted like a massive sunshade, blocking incoming solar radiation. The sun dimmed, the temperature dropped, and the world was thrown into what scientists call a volcanic winter. For years, global temperatures plunged by 3 to 5 degrees Celsius. In some regions, it may have been even colder, with localized drops potentially reaching 10, 15 degrees. This wasn't just a cold snap. It was a sustained, brutal period of global cooling. Photosynthesis slowed dramatically. Plants died en masse, unable to convert sunlight into energy. Ecosystems collapsed as the base of the food chain withered away. Mega herbivores struggled to find food, their vast grazing lands turning barren. Their predators followed, facing starvation as their prey dwindled. And in the middle of it all stood our ancestors, Homo sapiens, already few in number, now pushed to the brink. This wasn't just a challenge, it was an existential threat to our nascent species. According to the controversial Toba catastrophe theory, the eruption triggered a near-extinction event for humanity. This theory, first proposed by Stanley Ambrose, posits that the environmental devastation caused by Toba led to a drastic reduction in the global human population. Some genetic studies suggest that the global human population may have dropped to just 3,000 to 10,000 individuals, a genetic bottleneck that still affects our DNA today. The evidence? Across various genomes, modern humans show an unusual lack of diversity, a telltale sign of a dramatic reduction in population size. This genetic uniformity is particularly striking when compared to other primate species, which exhibit far greater genetic variation. It's as if all of us descend from just a few small groups that somehow survived the long darkness. This bottleneck is visible in mitochondrial DNA, passed down through mothers, and Y chromosome DNA, passed down through fathers, tracing our lineage back to a remarkably small ancestral population. This period of extreme pressure would have tested every aspect of early human survival. Resources would have been scarce, competition fierce, and the environment relentlessly hostile. It's a stark reminder of our species' fragility in the face of planetary forces. So how did we make it? The answers lie in scattered clues across Africa and Asia. In parts of southern Africa, archaeologists found signs of survival along the coast, shells, tools, and red ochre used for symbolic art. Sites like Pinnacle Point in South Africa provide compelling evidence of human resilience. These people may have lived off the sea, buffered from the worst of the climate collapse by exploiting marine resources like shellfish, which are less susceptible to terrestrial climate shifts. They adapted, they cooperated, they innovated. This wasn't just about finding food, it was about developing new technologies and social structures. The discovery of heat-treated silkrete tools, a complex process requiring advanced cognitive abilities, suggests a leap in technological sophistication. It's possible that this crucible of hardship forged stronger social bonds, smarter strategies, and more resilient cultures. The need to share resources, communicate complex ideas, and work together would have been paramount for survival. Some scientists even argue that this period of pressure helped trigger a leap in human cognitive development, shaping the modern mind. The intense selective pressures of the Toba winter might have favored individuals with greater problem-solving skills, adaptability, and the capacity for abstract thought and symbolic communication. This cognitive leap hypothesis suggests that the very adversity we faced helped forge the unique intellectual capabilities that define Homo sapiens today. But not everyone agrees. New evidence has challenged parts of the Toba catastrophe theory. Some archaeological sites, particularly in India, show continuous human occupation before and after the eruption, with no obvious signs of collapse. This suggests that while the eruption was devastating, its impact might have been more regionally varied than initially thought. Perhaps the volcanic winter was shorter than we thought, or perhaps the effects varied drastically by region, allowing some populations to persist relatively unscathed. Alternative interpretations of genetic data also exist, suggesting that the human bottleneck might have been a more gradual process or influenced by multiple factors rather than solely Toba. The scientific community continues to debate the precise extent of Toba's impact on human populations, highlighting the complexity of reconstructing ancient climate events and their demographic consequences. Still, there's no doubt, Toba was an event of apocalyptic scale, a geological force that reshaped the planet and profoundly influenced the trajectory of life, including our own. And the shadow of its eruption still haunts us, because Toba isn't the only supervolcano. There's Yellowstone, silently simmering beneath Wyoming, a vast caldera with a history of colossal eruptions. Its last major eruption was 630,000 years ago, and while scientists constantly monitor its activity, the potential for future events remains. There's Campi Flegrei, a hidden monster near Naples, Italy, whose caldera lies mostly underwater, posing a direct threat to millions of people in a densely populated area. Its recent seismic activity has raised concerns among volcanologists. There's Taupo in New Zealand, responsible for the largest eruption in the last 26,500 years, and several more around the world, from Japan to South America. Each of them has the potential to darken the skies again, to end harvests, to crash economies, and to test humanity's resilience once more. These geological giants remind us that despite our technological advancements, we remain fundamentally at the mercy of Earth's powerful internal forces. We like to think we've conquered nature. We build cities, we fly planes, we split atoms. We have satellites, global communication, and advanced scientific instruments. But 74,000 years ago, a mountain exploded and nearly erased our entire species. The survivors didn't have technology or governments or backup plans. They had each other, and they had the will to endure. Today, we carry their DNA. We live because they lived. Their story is etched into our very being, a testament to the incredible resilience of our ancestors. The next time the sky turns black, will we be ready? Or will we once again find ourselves at the mercy of the earth? The past has already spoken. The question is, have we listened? The story of Toba is more than just a historical curiosity. It's a profound lesson in resilience, adaptation, and the humbling power of our planet. Understanding these past cataclysms helps us prepare for future challenges, whether from natural disasters or other global threats. If this story intrigued you, share it with fellow history buffs, survivalists, and science enthusiasts. Hit the like button, subscribe for more deep dives into humans' most dramatic events, and leave a comment below. What do you think is humanity's greatest strength in the face of global catastrophe?